Today we will discuss about the automatic generation control. Uh, as all of you know that in our power system, load demand is very dynamic. Sometimes the load demand is very high and sometimes it is very low. So as per the load demand, the active and reactive power has to be controlled to meet the load demand. So at the generator side, a control mechanism is required to control few parameters, and it is known as the automatic generation control. But if it is not possible to control at the generator side, then load management is to be done at the load side, and it is known as the secondary control mechanism or the load side management. Now we know that the generator is generating the power, and it is generating the power at a particular voltage and the frequency. So in order to meet the required demand, we have to control the power. Indirectly we can say that we have to control the voltage and the frequency, which is the function of which is the controlling parameters for the power. So we have already read that to control the active power, we have to control the frequency, and to control the reactive power, we have to control the voltage. So from the discussion we can conclude that the automatic generation control is having the two parts, that is load frequency control and excitation control. The load frequency control means to control the frequency. Once the frequency is controlled, the active power will be controlled. The second part is the excitation control, which is used to control the voltage. Once your voltage is controlled, your reactive power will be controlled. So we can say that automatic generation control, it consists of basically the two things, that is load frequency control and excitation control. So this is the block diagram of automatic generation control. From here we can see from the left hand side that the steam flow is coming from the boiler and it is coming into the turbine through a governor valve, which is based on the fly ball mechanism. From this steam, the turbine is rotating and the generator is producing the electricity, which is, I have indicated all these things in the form of power, which depends on the two basic parameters, the voltage and the frequency. Now what we have to do is we have to control the voltage and the frequency. That is, we desired the required frequency, we desired the required voltage. So in today's lecture we will focus on the frequency part only, and in the forthcoming session I will go for the voltage part. So in this block diagram you can see that I have distributed the whole of the system into the two parts, that is LFC, this one, and the excitation control, this one. Fine. So let's start. So when the generator is generating the power, the two parameters are measurable, that is the frequency, which is I have shown on the left hand side, and the voltage, which I have shown on the right hand side. The entire mechanism on the left side is called as, or I have given the name it as the load frequency control, because here I will control the frequency. The right side is named as the excitation control, and because through the excitation we will control the voltage. Please do remember again that if we will able to control the frequency, it means we will able to control the active power, and if we will able to control the voltage, it means we will able to control the reactive power. So on the load side, if the demand is variable, it is not predictable, it is dynamic, we have to cope up with both active power and the reactive power. So this is, as I have already told you, that this is basically a primary control mechanism, where as per the requirement of our load on the load side, we will able to control our active as well as reactive power. So you can see here that first of all I will explain the left hand side part, where you can see through the generator the frequency Fg is coming, and I will compare this Fg with a reference frequency. Reference frequency means the frequency which I require, that is 50 Hz. Both will be compared in a comparator, and one output will come which is known as the Fe, or you can call it as the error frequency. Error frequency is nothing, it is basically the subtraction of the generated frequency and your reference frequency. Now from here, if you see the block diagram, the frequency error, the governor valve and your steam input, they are interconnected. So how they will work? See, if your generated frequency is more than the reference frequency, what you have to do? You have to reduce the steam inside the turbine. So what you have to do? You have to close the valve. You have to close the valve. This governor valve you have to close, so that the less steam will flow in the turbine, so that the Fg must be equal to F reference. Fine. We have to close until Fg is equal to F reference. Let's say the second case, if Fg, the generated frequency, is more than your reference frequency, then what you have to do? You have to open the valve. When you will open the valve from here, more steam will flow in the turbine, and correspondingly your Fg will start increasing. You have to increase Fg until Fg is equal to the desired value, F reference. Hence you can see that the governor valve is controlling the flow of the steam from the boiler which is coming into the turbine. Say if Fg and F reference are equal, there will be no error. You have not to change any position of the valve, neither you have to close it nor you have to open it. So by this method we will able to control the frequency level. Fine. Now how you will decide steam has to come inside more, or it has to come in a few amount? Basically it depends on the load. The more load will be there, it means you require the more steam to move the turbine. Getting my point? As we have already discussed in previous classes and previous semesters, that on a generator, if you will increase the load, your speed will get reduced. If your speed will get reduced, so using the formula F is equal to Pn upon 120, your frequency will get reduced. But you have to control, you have to make it in a proper limit. Say the desirable limits are plus minus 0.5%, say. So you have to control this frequency. It means you have to increase the frequency. So increase the frequency, what you have to do? You have to open the valve. Say we have discussed in the second case, when Fg is less than the F reference, because your frequency has reduced due to this decrement in the speed due to the increase in the load. Now say if your load has decreased, what will happen? Obviously you have to control your speed, you have to control your frequency, so that it should not be higher, because you are now under load or the no load. Fine. In this case you have to close your valve. When you close your valve, what will happen? The frequency gets reduced, and this process will be continued until and unless Fg is equal to your reference voltage, that is the 50 Hz. This is one of the best ways by which you can control your frequency with respect to your load. So see, this is the primary mechanism. In secondary mechanism, what we can do is, the load shedding is one of the methods. We have already read it in the previous semesters. We can reduce the load, we can increase the load. But see, generally we cannot force the customers to be in the limit, and not to change the load, to use this load permanently. It is a dynamic nature. It is in the dynamic nature. So the main process is that we have to control the frequency. See, one more thing you have to note here, that frequency is depending upon the speed of the turbine, because in machines in previous semesters we have read F is equal to Pn upon 120, where Pn 120 is the constant, P is the number of pole. So if you are talking about the frequency, it means we are talking about the speed. One more thing we can see from this system, that the response of excitation control is faster than the LFC. I have mentioned this point on the right hand side. Why it is so? See, because in LFC you can see a lot of mechanical parts are there, like turbine, your governor valve, boiler, fine. So the time constant is higher. They are having the mechanical nature. But if you will go for the excitation control, it is an electrical system. So the response time of, obviously, the right side system, that is electric system, is faster. The response is fast. They will take less time to react. Fine. So we can say that response time is faster than which one? The excitation control response time is faster than the load frequency control.